So I'm now going to go through the mathematical proof of differentiation. It's actually a pretty simple proof. It's not 100% necessarily that you can needed that you can recreate this, but it really helps cement the idea behind differentiation. It can be really useful if you understand it. So we'll start off just by looking at this graph. So we have f of x on the y-axis and x on the x-axis. So basically, the f of x is just a function evaluated at a point x. So this is the function f of x, this line here, and f of x, for example, here, is just the value of that function at the point x. And then we have another point, x plus L, so just a distance L, and then that is the same as f plus L, f of f plus L, so that's another point further along an x that's evaluated at different points up here. So basically we can get a general form for this, for differentiation, but again by using our gradient formula. So we'll take these 2 points, C and D, and then put these points into the gradient formula, and then we'll see what happens. Okay, so I'll just mark our points here. So point D is x coordinate is x plus L, and its y coordinate is f x plus L. And then our point C has point x, and its y coordinate is f of x. So if we get our gradient formula out again, so that's m equals y2 minus y1 all over x2 minus x1. So our y2, so this is our x2 point here, and our y2 point here, and our x1 point here, and our y1 point here. So we'll just put these in. So x2, so f of x plus L, f of x plus L minus f of x, and that's all over x2, which is x plus L minus x. So what does that simplify down to? Well, basically it simplifies down to this. M equals f of x plus L minus f of x all over L, because those two x's, they just cancel out. So actually this is our final form. This is it. This is the general form for differentiation gradient. So that was pretty simple to work out, but it actually becomes a lot clearer when you use it with an example of a derivative, and I'll go on in the next slide and show you that. So I'm just going to show you an example of using this formula for the derivative with a real example. So what is the derivative of x squared? So in this case we have f of x is equal to x squared. So we'll just plug this straight into our gradient formula. So we have m equals f of x, so that's f of x plus L squared. So we have x plus L squared minus x squared all over L. Alright, and what does that equal? Okay. If you have a bracket that's squared, there's a quick way of working it out where you just square the first term, square the second term, and add times the two terms together and double them. So you have x squared plus 2xl plus l squared minus x squared all over L. Now some things here will cancel out, so we can first of all see that this x squared and this negative x squared will just cancel each other out straight away. And then we can also see that there's a common factor of L here, here and here, so we can simplify that as well. So that then goes to L, brackets of 2x plus L all over L. And again, we can simplify this further by cancelling these two L's. So that just leaves us with 2x plus L. And this isn't quite our final answer, because if you remember back what I was saying in one of the previous slides, not this one, about trying to make the distance between the at which you're measuring basically zero, kind of really trying to approximate that down to zero. This is what we're doing here. So this is that distance L. So if you move this point D closer and closer and closer and closer and closer until it's essentially zero, that gives us the most accurate representation of the derivative at that point. So here we're basically just going to say that this L is approximately zero. So that's what that L means. It was approximately zero. So our final answer is 2x. So the derivative of x squared is 2x. So you might be thinking, oh gosh, that's a really long-winded way to work anything out. But luckily, there's a really easy shorthand way to do these kind of equations. But this is just kind of to illustrate where this idea has come from, why x squared equals 2x, kind of the maths behind it. You can try this with any derivative and work through the maths just to get a clear idea in your head, but it is not necessary. Anyway, I'll go on to tell you about that kind of general form in the next slides. Thank you.